Hello students. So we are doing continuity and differentiability. So we are going to solve some limit problems. Okay, that is linked to continuity. So these are the some of the important limits. Okay, please note them down. Let's solve exercise 5.1. Okay. First question: prove that the function f of x equal to 5x minus 3 is continuous at x equal to 0. Okay, so you have to check for the right hand limit and left hand limit. Now if you take here right hand limit and left hand limit, the value which you will be putting, that is x, will be the same, right? So we'll take only one thing, that is limit as x tending to 0, f of x is equal to limit as x tends to 0, 5x minus 3 is equal to 5 into 0 minus 3, which is equal to minus 3. Okay. Second, this is true. Now we have to look for f of 0, that is at that point. So f of 0 is also same. Okay. So we can say that f is continuous at x equal to 0. What about at x equal to minus 3? So again, limit as x tends to minus 3, 5x minus 3, put value of x, okay, which is same as f of minus 3. So this is also continuous. Okay. What about the third condition, that is x equal to 5? So limit as x tends to 5, 5 into 5, 25 minus 3, which is 22. Okay, which is same as f of 5. So here also it is continuous. So at all 3 points the function is continuous. Second one, examine the continuity of the function fx equal to 2x squared minus 1 at x equal to 3. So same way you have to solve this, limit as x tending to 3, 2x squared minus 1. So this is 70. Okay, and this is same as f of 3. Okay, so it is continuous at x equal to 3. Next is you have to examine the following functions for continuity. Okay, x equal to x minus 5. Okay, here they have not given any specific value. Okay, so we have to take any other value, say some c. Okay, so f of c is what? C minus 5, right? Then if you take limit as x tending to c, x minus 5, we'll get here c minus 5. So both are same. So it is continuous. Okay, if this c is a real number. Okay. Same way you have to solve for the second one, it is fx equal to 1 upon x minus 5. Okay. So f of c is 1 upon c minus 5, which is same as limit as x tending to c f of x. Okay, so here also it is continuous. But here only problem is if c is 5, then this function becomes not defined. So we have to define c in such a way that c is not equal to 5. C can be any other number, okay, but c is not equal to 5. So this c is from the domain, right? We are taking points from the domain. So this condition should be there for domain. We have to remove 5 from domain. Okay. Next is f of x equal to x square minus 25 upon x plus 5. Now here we can reduce this function. This can be written as x minus 5, x plus 5. This is your a square minus b square. So a minus b, a plus b. So you will get x minus 5. Now you have to take x as c. Okay. So c is f of c is c minus 5. Okay. Now our original function is this, right? So here if I put x equal to minus 5, then the function becomes not defined. So here also you have to keep in mind that you have to remove from the domain, you have to remove minus 5. Okay, then you can proceed further. So this is your f of c, okay, which is same as the limit as extending to c. Okay, so f is continuous at every point except this point. So this point we have to remove. Next is d, f of x equal to mod of x minus 5. So here mod is given. So how it is defined? Either it is minus x minus 5 and plus x minus 5. So this is for x less than 5. This is for x greater than or equal to 5. Okay. Now we have to take c in such a way that the function is continuous. So if I take c less than 5, then this function will, we have to take this function, okay. So first case is c less than 5. So we have f of c as 5 minus c, okay, which is same as the limit as extending to c, okay. It is less than 5, f of x. Now second condition is c equal to 5. C equal to 5 is f of c. Okay. For that you have to choose this function x minus 5. So this is c minus 5, which is 5 minus 5, 0. Okay. So if you approach from, that is limit as x tends to c minus and limit as, this is for 5, right? 5 plus. Both the answers will be same, which is equal to f of c. So it is continuous at c equal to 0. That is x c equal to 5. Okay, now we have to go for the third condition, which is c greater than 5. Okay, so f of c is this, you have to take c minus 5. Okay, which is same as limit tends to extending to c f of x. So here also it is continuous for greater than 5. Okay. Question 4, you have to prove that the function fx equal to x raised to n is continuous at x equal to n, where n is a positive integer. So this is positive integer. Okay. So first thing is this is defined. Okay, there is no 1 upon something or like that. So this is defined. That is for all positive integers. So our limit as x tends to n, f of n becomes n raised to n, which is same as f of n, right? So this is continuous. Okay. Fifth question, is the function f defined by f of x equal to 5, x is less than or equal to 1, x is greater than 1, continuous at x equal to 0, x equal to 1, and at x equal to 2. So first thing is check for x equal to 0. Okay. So the function f of 0, we have to take this function, right? X is less than or equal to 1. So f of 0 is 0. And if you take limit as x tending to 0, you will get the same thing, that is 0. Okay. So it is continuous at x equal to 0. What about x equal to 1? F of 1 is 1. Okay. So we have to check for left hand limit and right hand limit. So left hand limit tending to 1 minus, this is f of 1. So 1. Okay. And for limit as x tending to 1 plus, that is we are approaching from the right hand side. So x greater than 1, the values are 5. So we'll get f of x value as 5. So here limit, right hand limit, left hand limit and right hand limit are not equal. So it is not continuous at x equal to 1. Okay. What about x equal to 2? Limit as x tending to, okay, first you take f of 2 is 5. Okay, for x greater than 1 it is, and left hand limit and right hand limit of 2, we are approaching from the left hand side and right hand side, it will be 5 only. So we can take limit as x tending to 2, f of x is 5. Okay, so it is continuous at x equal to 2. So here you have to find points of discontinuity. Okay, so take one point, say C. Okay, and we have to prove that this function is continuous at that point. So what will be the cases? First case will be C less than 2. Second case will be C equal to 0. And third case will be C greater than 2. Okay. You can take 2 also. Okay. So if I take 2, then less than 2 means this is limit as x tending to 2 minus, that is your left hand limit. Okay. 2 minus, you have to take this function 2. 4 plus 3, 7. Okay. This is your left hand limit. What about right hand limit? For right hand limit, you have to take this function 2x minus 3. 4 minus 3, 1. Okay. So this is your right hand limit. What about c equal to 0? This is 2. Sorry, this is not 0. At that point we have to find. So for that you have to take this function because here it is given x equal to 2. Okay. So here your left hand limit is not equal to right hand limit. So the function is not continuous at x equal to 2. Seventh question, find all the points of discontinuity. Here also function is defined mod x plus 3 if x is less than or equal to minus 3 minus 2x 3 6x plus 2 x is greater than or equal to 3. Okay, so here the main point is 3 minus 3. Okay. So we have to start from here. It is given x is less than or equal to minus 3. So you'll here we have to approach from the left hand side, then right hand side, then again you have to go for this 3 also. So your LHL when limit is extending to minus 3 minus, okay, for that you have to take this mod of x plus 3. Okay, so mod x, you have to take the, if it is we are approaching from the left hand side, that is this is for less than, no? So you have to take this minus. Okay, so this is your minus of minus 3. So this is 3 plus 3, 6. Okay, now this is for x less than 3. Now we will be approaching from the right hand side. So limit as extending to minus 3 plus. Okay, so we are approaching from the left hand side. So we have to take this function minus 2x. Okay. So this is 6 and we have to find at minus 3. So at minus 3 means you have to take again this. So whenever you have mod of x is defined as minus x and x is less than 0 and this is x greater than or equal to 0 or that point. Okay, so at that point this is x positive, so this value will be positive, this value. So this will be mod of minus 3 plus 3, so this is positive 3 plus 3, so this is 6. So we are getting all the numbers, that is LHL is equal to RHL is equal to f of minus 3. So this function is continuous at x equal to minus 3. Okay. Then we have to check for f equal to 3. So first I'll write at f equal to 3. For f equal to 3, you have to take this function 6x plus 2. Okay. Then limit as x tending to, this is LHL 3 minus. Okay. For 3 minus, so this is your left hand side, you have to take this function. Okay. For RHL, limit as x tending to 3 plus, for RHL you have to take 6x plus 2. Okay. So here we see that LHL is not equal to RHL. Okay. So at x equal to 3, the function is discontinuous. Okay. Less than 3, it is continuous. That is, in this interval, minus 3 to plus 3, it is continuous. Okay. Next question. F of x is defined as mod of x upon x if x is not equal to 0 and 0 if x is equal to 0. Okay. So we have to find the discontinuity points. Okay. So this is mod of x. So it will be defined in two ways, right? For x less than 0, this will be minus x upon x. At x equal to 0, it is defined as 0. And at x greater than 0, it is x upon x, which is 1. This is minus 1. Okay. So this is our function. Now when you approach from left hand side, okay, then the value of the function is minus 1. Say any number if you are taking, not exactly at 0, okay, any number, say c. So when c is less than 0, so we are approaching from left hand side, that is LHL is limit as x tends to c minus, then the value of that function is minus 1. What about RHL? As we approach from the right hand side, value of that function is plus 1. Okay. And at that point, it is 0. That is our 0, x equal to 0. Okay, when c is equal to 0. So we can take c less than 0, c greater than 0 and c equal to 0. Okay. So LHL is not equal to RHL. So function is discontinuous at x equal to 0. Okay.